Good evening, everybody. Welcome to this build show. We start this season of the build show on Modern Routing Live. I've got a couple of gentlemen to join us, and we're going to recreate some conversations, basically. We'll bring Robert and Ralph back to the situation. Good evening, gentlemen.
Howdy.
Evening, evening.
So, and any of you guys who have joined us for the late night shows, and even for a few of the Johnny's talk shows, and some of our, and even Empires, where we've talked about this briefly, I've had a conversation for 2 years, probably an ongoing conversation about a concept of how my layout had to be manipulated to fit in the space. That's the biggest constraint I have, is that I'm trying to pack quite a bit of density into a relatively small space, a 15 by 15 foot layout. Many of you guys have seen the layout design. It's matured a bit over time, and I'll show you guys an updated version of the top deck of it tonight. And we'll talk about how this layout, briefly talk about how the bridge that I'm going to be constructing over the next few episodes, how that's going to fit into this, and why it's not just a scenic element that could have went anywhere, cut out a little plywood, stick a bridge in. That's pretty simple. It's both critical to design, and because of the three-dimensionality of it, because of the elevation and such, it gets kind of complicated to make sure that it fits correctly, that it looks prototypical, that it functions as the job it needs to function, it doesn't get in the way, largely because of how large it is and how it fits in the scene. So it's a 6 foot bridge. The model is a 6 foot bridge, roughly, at 83 and 84 inches on a very slight curve, on a grade with helpers. So, and it has no side, it has no protection, so it has to be pretty well right. So me and these couple jokers and a bunch of other fellas that have had these conversations with us, I mean, there's been 30 or 40 conversations about how best to deal with certain constraints, how to make it fit in, how to build it. Um, Especially on Ralph has already built a bridge that's somewhat similar. Maybe not, maybe not 7 foot off the floor, but it's 6 or 7 or 8 feet long, right, Ralph? It's
Yep,
pretty significant.
8 feet.
Yeah, it's a significant bridge. So his construction methodology, and I've seen a few others do as well, has informed my design a whole lot. And then me and Robert have hammered back and forth for a long time on layout design, on my layout in general, and somewhat more specifically on this bridge.
Yeah, and we've used a lot of different tools to do that too. One of which is SketchUp, believe it or not.
Yeah, we've had to do, because of the three-dimensionality and because of some of the complexities that I've enforced on myself to some degree, by trying to get as close to the prototype as I possibly could. I mean, I think it's going to be relatively impressive, regardless of how exacting I am with it, considering its size.
But
So
as we all are aware, the challenge is getting from the mental picture we have to the actual physical object that we're trying to do. So
Exactly.
yeah, that's a big part of it. And what compromises you can make, and then how to fit it into a layout. And I think that's always complicated with layout design, especially if you're a prototype modeler to any significant degree. But it's a two-dimensional problem. Pretty much any realm, third planet, etc. These are essentially 2D drawing applications. There's some 3D components, but they're predominantly 2D CAD or CAD-like pieces of software that you're designing in. But my layout, much like what you're designing right now, Robert, is so significantly three-dimensional. I mean, it's going over your head at spots. There's raised platforms and different flooring elevations and levels, let alone complex track work. I mean, there's one place where the bridge ends up on the far right side. There are 9 or 10 tracks, if you in the plan, across multiple levels. They go all the way from 83, and then a 79, 78, then a 73, and then a 61, and then I mean, and then several levels below that. It's really complicated, and some of those levels are somewhat close together. So there's a lot of complexity of making sure that all of those levels work out right, that you have reasonable grades between them. And those are, physics constraints that you're dealing with. Then you have structural and construction constraints. It's one thing to find something that fits in the space, but you've got to be able to build the thing too. And that's been part of the longest running conversations I think we've had about this thing, is how it fits is one consideration that took a little while to work out some of those final details on how to actually construct the thing so that that it is solid, that it is constructible, and that it's
Except
solid and stays solid.
The problem over the past 2 years for a lot of things has been the analysis or the paralysis by analysis. You overthink things, right?
Absolutely. And the number of versions I've had of this, just this one part. I mean, in my any route diagram or any route track plan, this bridge has changed formulations. It's changed curve profiles from straight to curved and back again, and changed curve profiles to be more and more exacting as time has went on. For the longest time, I didn't think I could fit that curve to make it work out correctly. And for a period of time, I actually was reversing the curve, but I think it looks better when the curve is, to me, it looks better the closer to prototype I get. And that curve's really mild. I mean,
1/64th of an inch.
Yeah,
Yeah.
and here's where I come in. I keep telling you, you don't need that curve. You can put the curve in at the end instead of in the middle of your bridge.
Possibly. I've been trying, my current design calls for it to be a continual continual curvature across. Actually, let's take a look while we're talking. Let's start taking a look at
Okay,
some
but the
content.
first thing to consider when you're doing a bridge, bridges are except for European, and don't even go by European. Your plate girder bridges, which is the kind of bridge you're talking about, are not curved. They're actually straight sections that are built and joined on angles. It's the track on them that curves. So they're, in order to allow for that curve, they're made slightly wider.
Sure. Yes, that makes sense. And it
So
is a series of straight connections.
that might be your saving grace, is the fact that the curve is making it a little bit wider, because your concern is something falling off. And I keep telling you, I've been running an 8-foot bridge here and never had anything fall off it. And my track, it's not fastened down to the I used aluminum channel,
Right.
and it's just slightly narrower than the track ties. It's probably the same width as the rail itself, and I've never had any problems. And because it's flat, and it's also a grade, but because it's flat, it's not moving on me. And right now it's flex track.
Yeah.
I plan on replacing it with flexible bridge track, and then microengineering decides they're going to go out of business. So now on my bridge track, I'm up in the air. I don't know whether I'll be able to get it or not.
I think that the biggest thing to account for first is Andy going for prototypical, or is he just going to make it fit?
Absolutely.
And we all know the answer to this because we all know Andy well enough to know he's going prototypical. So the next question is the bridge in real life, does it have an arc to it, or is it straight with a curve at the end?
It is. So let's start looking at some of the content I've got to share with you guys about this thing. So this is the bridge. This is the exact bridge and where it fits, where it is. This
Can you
is
zoom
called,
in on it a bit?
Sure. It's called Kennedy trestle. There are 4 of these, all fairly large. I'm modeling all 4 of them. There's about 4 of them within about a mile and a half or so of each other. I'm modeling all 4 of them. This is the second one in the sequence, but when you first walk into the room, it's the first thing you'll see when you first pop up into the layout from entering.
Okay, so obviously it does have an arc to it over a span of what's probably, I'm going to guess, 1,000 feet, maybe a little less.
600. It's 600 by the measurement. It's 620 feet. By the technical drawings, it's 624.
Okay, so now from 624, you can reasonably assume, I think at least, that the individual sections are in fact straight, but the angle of each section at the entrance and exits are just slightly off from square.
Mm-hmm.
So that's going to give you that arc effect, right? Okay.
Absolutely.
So in previous conversations, Andy and I have already kind of figured this out, and the exacting detail on it is incredibly insane. And I almost want to say kind of pointless, really, as tight as the margins are on it, right? So, Andy, I'm going to screen share this real quick so everybody can kind of see what we're
Oh,
going
absolutely.
on about here.
Yeah, let's look at the curvature of the model as well.
So this is from entrance to exit, exit being at the bottom, I believe, and you can actually see it. It has that arc on there, right? So over here, though, I actually measured this out, section to section, and what we've figured out is the inside needs to be 5 45 64ths, and the outside needs to be 5 46 64ths. It's 1/64th fourth of an inch difference from inside to outside. That will give him the overall arc that he's looking for over the 11 bridge segments. I was trying to figure out before the show started how I actually got to this, and for the life of me, I can't remember. I think the last time I looked at this was probably a year and a half ago. But I was actually able to draw it all out. That's the actual width of the bridge itself. Basically an inch wide. So it's gonna, exactly the rails and the ties are exactly wide enough to fit over this whole thing. So it's gonna be, I mean, what is it? Probably an inch and 5/8 total, if that. So I mean, it's not much, and I don't see how adding 5/8 of an inch to the width of it is going to change your total differences on your inside outside by much more than a 64th, maybe 2 if we're being generous. But it's very exacting.
And to me, by adding the curve, you're creating more of a hazard of something falling, because now you have to allow for that extra weight that's being put on the outside of that circle, instead of straight through. If it's straight through, it's equally balanced inside, outside.
Right. Otherwise, it has a rotational force on it because it's curved slightly.
That's what I'm talking about. You have the weight going to the outside, and that's not always great if it's going to want to twist. And what you want to do with the aluminum channel by breaking it up and so on, you're taking the integrity of the aluminum channel away.
And it does have to be cut for that 64th. You have wood.
Well, actually, a hacksaw blade through one side.
Yep.
And then bend it inward.
And that's another thing we had talked about doing, just marking that and then cutting it with a hacksaw and then bending into to meet where we need to go, because then at least it maintains the structural stability on one side.
So when I did mine, I did it straight, and I got these. I think these are microengineering. They were actually designed for flat car loads.
Mm-hmm.
It comes in 2 pieces. There's a joint in the middle here. But what I did is I shaved off the ribs on the back side. I don't know whether you can see it.
Yeah.
On the upper part. So that's where the aluminum channel sits. And I epoxied it to the side of the aluminum. You can't tell the difference because the rail actually sits on top of the plate girder. The ties sit on top of the plate girder.
Yep.
You can't tell the difference. And to me, it was the safest way of doing it.
It is a bunch of straight segments on the prototype. You can see even on the prototype, it's a pretty mild curve. To give you an idea of how mild of a curve it is, I believe the radius was 22 feet of a radius.
And in that case, it works fine because it has your trestle bends supporting it at every joint, right?
Yep.
Whereas you can't do that on yours because you're going across the opening of an aisle.
That's right. So I can't have all of them. So these 2 in the center are eliminated. They'll
right.
have a little bit of framework underneath them, so you can see where the bits go.
Oh, that's going to be mainly cosmetic.
Absolutely, it serves zero functional purpose. But from this tower on the left end to the tower on the right end, the horizontal offset, I guess you would say, is like an inch. Basically, it's out of straight by about an inch. And if I could lock my instinct about it, and we'll find out how successful I am over time at this. But my instinct about this is that since it's so mild of an offset, as long as I can lock both ends into to the roadbed at the edges of the bridge, at the abutments, if I can lock that in significantly, I'm even going to run the aluminum on past the abutment so that it's locked into the roadbed significantly, which gains structural strength for the peninsula and to the wall section. And so if I lock that in most significantly, everything's glued together quite securely, and it's supported by those two towers, which are largely cosmetic, but they do support it to keep. They'll reduce the rotational loading.
Okay, so you say it'll be locked in quite securely, except your method of construction is styrofoam.
Well,
Are you going to have wooden frame modules in that area?
so everything so far, everything on the top deck is currently wood frame construction using the C frame modules that I have converted to. That I am so happy, and I like styrofoam. It was great. It worked really well. I'm not against that. What caused me trouble with styrofoam was the complexity of my design. The design with all the three dimensionality got really complicated to do. If I had stuck with my original track plan, um, before we ever started the Empire show, and I really started hammering out a layout design, I started realizing how many opportunities I was not taking advantage of.
You're welcome.
The styrofoam worked fine. Yeah. And I kept with designing it on, on paper. It was a simple design, relatively simple design. But as I started putting it into CAD and realized there was more and more opportunity that I could do more and more stuff with it, then the thing grew so to where it was so much more complicated. If it's a flat layout, I think styrofoam on shelf brackets does the job. I completely stand by the construction method for single deck layouts. But since this layout has so many, I don't know if you can call my layout clearly a two deck layout or not. I mean, you kind of can, but there's so many levels to it. It's a no links. It's a continual incline. So it's really complicated to define what it is because it has some mushroom components. It has some multi deck components. It has raised floor. It's a complicated design. But and this became a constraint because the peninsula in the space, if I had a 16-foot wide space, it wouldn't have been a big deal to get the turnback curve. But I had a 15-foot space. And I had designed a 2-foot section of benchwork from left to right, 2-foot section of benchwork. It was originally styrofoam. Now I'm going back and wood framing under those in C frame modules. But it was a 2-foot section and a 26-foot aisle, but let's say 2 foot. And then on the other side, 2 foot and 2 foot, you're taking 8 foot. You're left with 7 foot or a little less than 7 foot, actually. So getting a turnback curve to get the correct turns was relatively difficult, especially at the kind of radiuses. My visible main line is a 34-inch minimum with easement, so more like 36, but it's also longer. It can be 36 wide, 30 or 6, 64 wide, but it's longer in the other direction, and that didn't work. So then I got the idea of, well, once I'm already on the top deck, because at that time I wasn't going to build any raised floor sections. I was just going to put the top deck at 84 inches or something in the air. It was going to run out of the model, the lower deck that I had modeled, run out of that. You had some open running to the end where pushers were uncoupled. Then I designed, I was going to do a little step stool arrangement there so you could reach up to uncouple the pushers. And then that design grew to, let's say, slightly more complicated. And but the peninsula, it made more sense that the peninsula at least needed to overhang the aisle. That's when I started getting the idea, well, what if I just go on past the aisle, go across the aisle? And if I have to do that, why not make it a scenic treatment? Why not do it as, well, like this? So you could, we'll start briefly with the 3D, which is not perfect, but you get an idea of where it is of the layout. So when you first enter the layout, you come in from here. All of this layout is the top deck. The lowest elevation on the layout is over here at 73, 74 inches. The highest elevation is back in the back left corner where the track goes to 88 inches. So 8 inches from the ceiling. So, and when it first comes out on the layout below, the lowest level of the layout is at 49 or 50 inches. So you're basically climbing from 50 inches to 88 inches over the roughly 200-foot visible main line, or 200-foot end-to-end model mainline. But when you first come in, there's this first bridge. That's the one I'm modeling with the slight curve. It's be supported by towers on both ends, and the horizontal offset is not very significant. And it may prove to be a problem. I have a couple that go over aisles also, by the way. There's the other one that's back on the back section here that also goes over aisle, but this is a much simpler straight bridge. This is Hamilton trestle, and this is the first one in the sequence, and then Kennedy trestle, and
I think it should be straight.
But
That's
Kennedy,
my opinion.
this one is straight, and it's a simpler bridge. But this other bridge is curved prototypically, so I've tried to try to fit that in. If it ends up costing me a whole lot of trouble, I can't always convert to building it straight. It's possible. I mean, it fits straight. I have a design for it. I have a design for it straight. Well, I have a design for it the other curve too. I have a bunch of different designs.
But you know what though? I mean, straight is going to be easier to do. But when you walk into somebody's layout and they've got that big, gigantic curved trestle, there's such a much bigger wow factor in a curved bridge than there is in a straight bridge. And I think
except when you're looking at it straight,
way to go.
When you're looking at it straight, you're straight on. You're not going to see the curve, so the wow factor is not there until you walk over in the corner.
But you're looking up under it. So you walk in, you enter the layout in this bottom right corner. So as soon as you pop up here, and it might be easier if I turn off the extended steps, but as soon as you walk under the layout and stand up right here, you're looking up at that bridge too. It's way, and it's at 83, 84 inches. It's above everybody's eye level and significantly above mine. And so you're looking up under it. You'll be able to see that curvature, even as mild as it is. From end to end, the offset is more like 4 or 5 inches, but the offset between just these couple towers is only 1.5 inches or so. But I think, so back to the construction methodology, I believe all the current and all the top modules are going to be built in the C-frame configuration with the wood substructure and the C-frame design. And in the yards and areas where I have quite a bit of track on the modules that you've seen me building on the Empires series that finished up last month, there's multiple tracks there. There's yards, turnouts, and a lot of divisions. So they are flat built. They're homosote with spline underneath. So they have a flat deck of homosote. On the connecting roadbed to this, it's just homosote spline. Everything's everything is vertical homosote with the slopes on the side and such. So I can run that U channel. I can take the top off that U channel and just run the two sides of it right back into the homosote. I can lock that in significantly.
Why take the top off?
Well, I'm not sure I would. My thought on that would make it easier to keep the track back on homosote at the edge of at the abutment.
So the way I did mine is once I got it into place where I wanted it and I had it level and I had the supports that it sat on because the channel came down over the support, and I'm talking a piece of wood like that, 3/4 inch piece of wood. So my channel fit right down over it with just room to spare.
Yeah.
And rather than screw it into this way, I wanted to make sure it stayed solid this way. So I screwed into the top of this. And if you take the top away from the channel and you only have the sides, you're not solid to your framework on either side.
That's why I would have had to squeeze it basically to keep it true.
Yeah, and you're more floating when you
do it from the side. Remove it? So keep in mind that this layout is movable, not portable, but it's sectional. And it needs to be relocatable for whenever I get a building or build a new home. I want to be able to relocate and repurpose all of this. It needs to be, yours is essentially removable, but keep in mind that my track work's not easy to remove because this will be hand laid track.
So we're working on the premise that you still want to be able to look up through it, right?
No, I believe I've pretty much give up on that concept. For a long time.
I've given up on telling them to make it straight. So.
Fair enough. So we're going not being able to look through it, and we're going to go curved. Beautiful. Yeah. So then don't worry about it. If you don't need to be able to look up through it, then leave the top on there and the top on your C channel, and you're good to go. That's an easy fix.
Well, across the top of the bridge, I definitely leaving the top on it. The only consideration is when I get to the ends. If I want to run it back into the roadbed 4 inches or 6 inches to give it to kind of keep it from wanting to twist on me. I had thought about topping the top of the U channel so that I could get the track after it crosses off the bridge onto the abutment, so I could get track back onto Homosome.
No, exactly the opposite. Exactly the opposite is what you need to do. You need to leave your 3 or 4 inches on each end, and then just whatever supports you have, notch that down the width of your material.
Exactly.
So that when you come off, it's flush with the edge of your Homosome, the top edge of your Homosome.
Yeah, that's true. I could talk that.
You build something like this, which is only the thickness or the depth of the channel.
Sure.
Mm-hmm.
So that it sits on here, it's got solid bearing, and you have this mounted into your ends of your layout, and you can fasten to it.
Yep.
Either way, I think that'll be removable either way without it being. I don't care if there's some
The
destruction.
removable part of it for me is I have, and you're gonna nix this for sure because you don't like rail joiners. I put rail joiners at the end of the bridge to hold the track in place.
Yeah.
I make it so that I can remove a few ties, slide the joiners back, and the bridge lifts right out.
I've done that.
I think that's one place you really need to compromise on that one.
And where you slide the ties out is where your screw is hidden by the ties.
That's true. I could make a couple I could make a couple ties probably removable. But then you still got to scrape the ballast up and all that stuff if you're talking about joining it back under the ballast. But I think, well, one of the constraints is on the right side of the bridge arrangement, I don't have to worry about that. On the left side, it is scenic. There is more scenery involved in that. But I don't think that's going to be a significant design consideration. Regardless, as long as it's structural, I'll find a way to hide that stuff. And the way I'm going to deal with the rail joiner situation is I've got the brass or phosphor bronze, whatever they are, etched rail joiners from KV models, because I have to have rail joiners, or I have to lengthen 36-inch segments of rail across a bridge that, if the 620 foot, by the way, back to length briefly, 620 foot to scale is roughly 7 feet, slightly more than 7 feet. I'm modeling it 6 feet long. That's how much space I have. So I'm modeling it 6 feet long. So it's slightly compressed, but pretty slightly compressed. That's still longer than rail joiners are going to allow for, or that a single section of rail would allow for. So KV Models has these brass fish plates. I could solder those on both sides of the rail. It effectively works like a rail joiner. It solders the rail together in a significant way. And then one joy of that is you could take those two fish plates, solder them onto wood rail, and then you could always slide the rail and just solder the wood rail and leave the other rail not soldered. So I'm going to do that in several places anyway, so you have expansion and contraction. But I could also do that so that the bridge could be slid out from.
Can you explain that again, because that went right over?
So basically, he's just saying that he's going to solder one side of the rail joiner and leave the other one unsoldered so that he has expansion and contraction. But what he's not thinking about is that when he does that, he's going to have to bend the crap out of that flex track to get it to release. You need to leave it unsoldered on both sides so you can slide the whole rail joiner out.
Yep.
Well, okay. So the fish plates that I'm talking about aren't truly a rail joiner. They don't have a bottom component. So the only way they hold on is it's just the fish plate. It's just the part of the prototype.
They're 83 inches in the air. Who's going to see your rail joiners?
True, but there's raised platforms right there beside of it that put you right close.
I'm sorry, man, but in this case, the rail joiner method is just wrong, just flat wrong. The fish plates is wrong. You got to go with the rail joiners, and then if you want it liftable outable, because otherwise, what's going to happen is if you use those fish plates, even as cheap as they are, when you go to pull that apart, you're gonna snap them. Because you're going to have to put enough edge on them to get them to break loose, and you're just going to break them. You might as well go with a rail joiner that you can just pinch and slide out of the way.
Sure. Well, and even if I have to have rail joiners on or on both ends, now the right end doesn't matter. It's not significant because there's no place where you can get to see that significantly. But even if I have to have rail joiners on the left side, I could find a way to hide that. The most significant constraint was going across the length of the bridge. You have to join those 36-inch segments of rail But those brass KV models fish plates let me do that without having to have rail joiners. And which there are other ways to solve that problem. Rail joiners are not the only way to enforce alignment between track. And I do not need rail joiners for electrical conductivity. I am one of those people who believe in a feeder to every segment of rail. Every segment of rail. So I don't use that on electrically.
And I'm with you there. I put feeders in every 3 feet on every piece of flex track that I have. So I'm with you on that. But when you're talking about making it easily liftable, outable, or movable, or portable, you're better off just going with the fish plate or with the rail joiners and just leaving enough room for them to slide. I mean, you're only talking half an inch. It's not that big of a deal. And people won't really see it once you get it all put in there properly.
And I can hide them. I can hide rail joiners in a few places. I do use rail joiners in some places. In staging and hidden track, I do use rail joiners. I take the easy way out. I don't do things the hard way every time. Unless there's a reason to do it the hard way, I don't do it the hard way. I use rail joiners there. And some of this track work that is on the modules that I've worked on for the Empire series, there's rail joiners on some of that track because it's buried in coal, ballast, dirt, etc. So there's no reason to not use rail joiners. The problem I have with rail joiners is not a physics or mechanical problem with rail joiners. It's a cosmetic problem. So as long as I can hide them cosmetically, it's surely in one or two places you can hide them.
But in this case, the rail joiners are added safety for the rail.
Yeah.
They keep it aligned.
Yeah.
And you don't stand the chance of a rail going slightly off because something moved, and the next thing you know, your $300 locomotive has been turned into a kit.
Yeah.
By gravity.
Yeah, my favorite. I love what SpaceX and the space industry talks about when a rocket explodes. They call it an RUD, a rapid unscheduled disassembly.
Mm-hmm.
So when a rocket blows up, so I love that thought. As long as it's not my millions of dollars that was trying to get to space that blew up, it's not a big deal. And this is not an unreasonable constraint. I mean, 7 foot is a long way. I mean, that bridge is way above your head, and it's 7 feet.
Mine's 8, and right now it's only supported at either end. I don't have my towers in the middle where I want to put them yet. And
I think I'm going to depend on my towers a bit more. I think I'll depend on my towers a bit more than you do, just to handle rotational tendencies.
He's always worried about that twist. Always worried about the twist.
He's worried about the twist. The easiest way to eliminate the twist is straight.
No question, straight is easier. I have no disagreement that that's easier, for sure. I have 4 to build, though. 2 of them absolutely must be curved, but they don't have to go over aisles. That makes that much easier to deal with. They're supported under the framework. One of these others, than what I'm going to building first, I would prefer it to be curved. If it turns out that it causes me some trouble in the construction, then
it's a 6-foot bridge. You're saying 7 feet, 6 foot, 7
it's 6
feet.
foot modeled to be about 6 foot.
Your aisle way underneath it is 2 feet or more.
It's 30 inches under it.
So for 30 feet, you have no support whatsoever except for the channel.
That's right.
And you're adding the external stress to the outside.
A little bit, but it's 6 foot. It's 6 foot of rotational tendency that's offset by an inch. There's an inch at the outside of the curve.
And on top of that, you overweight your cars.
A little bit.
You also have probably running 2 locomotives.
3 plus 2 on the rear.
3. So there's a good 1.5 pounds, maybe more, of locomotive going across that thing. Once that twist starts, if it's not connected properly, it's going down.
Well, you could hold it'll just coal hoppers, loaded coal hoppers, loaded coal hoppers. There would be about 12 on the entirety of the bridge, maybe 6 across the section over the aisle, but 12 coal hoppers weighs about 8 or 9 pounds with the way I weigh them.
But see, the other thing is so Ralph, you're kind of skirting both sides of this argument here, which is kind of fun to listen to. But you've already made mention of screwing down from the top to secure it in place. Okay, so if you do that on both ends, you're essentially going to eliminate that whole twisting effect anyway.
And it has power.
But he's not convinced of it.
Oh,
That's the
it has to
problem.
be solid. So it has to have the only way the curvature arrangement works. It absolutely requires two considerations. It must be solid on both ends, and it must resist twisting. That's all you can do is resist the twisting force because that force.
So I mean, this is not complicated. So the problem we have here is we're failing to remember the KISS method.
Yeah.
Keep it simple, stupid. All right.
Yeah, it's hard to make it simple.
So cut your notches, like we talked about. I personally would use a jeweler saw to make sure it's as thin as possible. Bend it into place, and then JB weld that sucker back together.
Yep.
I would use JB weld because actually welding aluminum. If I don't have those tools, I don't think.
No, don't bother
epoxy.
Aluminum.
It's going to be epoxy.
So so I would JB weld them together or epoxy or whatever, and then when you go to set it in place, screw it down from the top. You're done.
Your joints, just make sure you reinforce them with maybe a piece of sheet metal or something on the inside.
I thought about that.
You're gonna paint it anyway.
That's right.
Or even a piece of styrene that's epoxy to it. But in order to score the styrene so it holds to the epoxy, it has to be of some thickness, and the thickness you'll actually see.
But yes, there's going to be. I definitely have to have something structural to epoxy inside of it as well, even though one of the walls will stay consistent and hold the length of it. But to keep that twisting force, epoxy does pretty good and it ages pretty well. But also, I can hide quite a bit because that U channel that's constructed from is, say, 3/4 of an inch, 5/8 of an inch tall, something like that tall. The bridge girders are 1.25 inches. So you have another 1/2 inch up under the bridge girders between the two girders. You have another 1/2 inch of space before you could even see up in there, and it's entirely dark and going to be painted black and hidden.
Well, if you paint it black, then it's really dark.
Yeah, it's going to be the bridge is going to be black. Just
So the side of the channel is 3/4 of an inch.
That one is. I'm using the inch and an eighth. It's actually like I think it's 1 3/16 inches. The ones I'm using. Actually, while we're doing this, let me start sharing some pictures too. We'll just look at some pictures of of the prototype, and you can see how large this thing is too. Let's see.
Where did you buy the aluminum at and you said 1 3/16 inches?
So the 1 3/16 inches is the plastic girders. The plastic girders are 1 3/16 inches or 1 inch, and they're just slightly less than 1.25 inches.
They are 1.25 inches, the plastic girders.
Yeah.
I'm saying the side of the aluminum is 3/4.
Yes, that's right. That's what I'm saying. So you have 3/4, and you have 1.25 inch bridge girder. So then when you're looking up from underneath, that aluminum is recessed up between those two girders by 1/2 inch. So anything you're hiding up in there, and it's complete, and it's painted black, and it has all that cross bracing underneath. I don't think you're going to be such that it is that I am not constraining myself to where you could look up through the ties. It's going to be so dark up in there. I don't think it'll be a problem. And I'm just going to cruise through some pictures I had of the prototype while we're sitting here.
And really, you could probably use a tin can. Just get you a soda can and cut it into strips and use that in the back just to give it a little extra support. Doesn't need to be super sturdy or anything.
Well, no, you can also use the aluminum foil duct tape.
Yeah.
Yeah, I got that.
That'd be the easiest way to go.
Yeah, I've got that stuff. That's really handy for a bunch of things. I use that for a lot.
And it's pretty strong too.
Yeah, absolutely. And you can see it is, it is just very, even on the prototype, which is a spectacularly wide curve.
Zoom that in a bit, will you?
Sure. It's a very slight. It's a very slight deflection from straight to straight to straight to straight. And a very interesting kind of weathering effect that these things do. But if you see these.
Oh, let's not get into the weathering right now.
No. We're not having that conversation tonight.
Yeah, we'll get there.
That's a whole other argument.
Absolutely. How we're going to do that's a whole other constraint. But the sides of the girders are, they're not as tall as a locomotive, but they're nearly. And if you've looked at anybody who's looked at the microengineering steel trestle or steel viaduct, whatever different railroads call them different things. If you've looked at the microengineering steel trestle system, which I'm using their towers, bits, towers, whatever, I'm modifying them. If you've looked at the microengineering, they have a cross brace across side to side. These do not on this prototype, so I'm modifying mine. But on a lot of those microengineering kits, they use actually, I guess all of them, they use different size bridge girders across the top of the tower as opposed to the span between the towers. So that's why I have to cut up bridge girders and make this myself. I can't just use a factory um, kit to recreate this because the bridge girders are the same height all the way around, and they're not hardly the height of a locomotive, but more than half the height of a locomotive. This is and these are there's 4 bridges in that area. This is a range of pictures of those 4 bridges. This is the shorter bridge that'll be on the other side. Actually, that might be that bridge. I'm not sure. But with it all
painted. Look at that! Look at that loco. That's cute. I like it.
Yeah.
Looks like
Burlington Northern.
Oh yeah, BN. That's an old one too at the time.
An SD45.
Well, it's been patched for BNSF too. So this is a fairly late, reasonably late picture, but and this is something that you'll see in years to come when I model the other bridges. This is one of the shorter bridges. This is one of the 2 bridges that are together that are the big Lawson and little Lawson trestles, and they terminate in the trees on both sides. You really can't see the ends.
Zoom that in again.
Yeah.
Yes, so you see the locomotive. I mean, the walkway on the locomotive is probably right at the edge of the bridge, maybe even hanging over just a touch.
Yeah, I think I have a picture. I do have some pictures looking from the end, so you can get an instinct for how.
Yeah, look at that. That's crazy.
The loco actually hangs over the ties.
That's right, and that's why I can't protect the equipment. So my track work has to be spectacular.
You can. There's the what do you call them on the sides there? So they're the wooden guardrails.
Guard timbers. Yeah, guard timbers. Yeah. And that protects from some considerations. But if you have any, a significant tumble, that's another reason why I really believe in overweight of a lot of rolling stock. They really gravity really wants to hold it true.
This to me, this is where your prototype for your application of this bridge sucks. You should have on that bridge for your application steel guardrails in the middle.
Oh, sure. Actually, so that picture is fairly late. This is pictures from my time period, and they are guarded, and I will have guardrails on them. So that picture was later.
Wow, that was easy.
Hey, as long as it's prototypical, he's not going to argue with it.
Wow.
Don't get used to it. But whatever was there in 1986, and I make some compromises. I do selectively compress, and I make some compromises.
Why was it missing on the other picture? Maybe that wasn't the same bridge.
Right. These are those 4 bridges, but they don't.
Maybe you've been stringing us along all along.
Well, I'm sure that's true to some degree. So as a starting argument, but I think it has to do with as they have been coming back and redoing track work post 2000 sometime, some of the bridges don't have guardrails anymore. I don't know what made that concession by the railroad to stop doing such a thing, but in the later pictures, you see a couple of changes that have happened more recently. Let's say the last 25 years from the early 90s up. In the post Norfolk and Western era, in the Norfolk Southern era, some changes have happened. In the Norfolk and Western era, effectively all bridges were black. Just about all bridges. There were rare exceptions to that. They were pretty much all black. But there are some silver bridges, and of these 4, one of them has been repainted in silver.
I saw that picture was in silver.
Absolutely, since 1986. I actually have some pictures of.
Did you see what was on the screen?
Oh,
you missed it.
What's that? Oh yeah, absolutely. And what's
No,
interesting,
that one.
well, so I was an Ellen. I've been an Ellen modeler much of my life, and I do model the Ellen. And part of the joy of this track work, this is a Norfolk Southern track, yeah, Norfolk and Western formerly, Norfolk Southern, and Ellen has trackage rights until early 1987. I'm modeling 1986. So until the CSX merger was truly complete, and until they had some other track arrangements, Ellen came over the line, come down to the town that's on my lower level, what I call deck 3, but on the lower level of my layout. They come down there and dropped loads and run the locomotives back light to St. Paul, the town I'm modeling on the lower level, and held over in the track that used to be by where the depot was. Held over until a northbound train coming out of Kingsport, Tennessee, brought a set of empties up, grabbed the loads and headed south, and then his light locomotives drop out, run that mile or two out of town. Again, I'm modeling all of that, and then head back north up this same trackage across all these bridges. So I get a model, Norfolk Southern with Norfolk and Western and Southern livery locomotives, as well as the Louisville, Nashville in early CSX days making this trackage rights run.
So we're getting a lot of comments about people being worried about your trains falling off and turning into kits.
Yep.
Yeah.
And I think we could, that problem could be easily addressed for the most part by using continuous rail through the entire bridge.
I'm going to try to make it as close to continuous rail as I possibly can.
So we all know that the problem with continuous rail in the hobby is they pretty much only come in 3-foot sections, and we're talking about at least 7 feet across.
I'm going to try to solve that.
So what I would do, my solve for that would be to solder them together.
Yep. Absolutely, I am. They will be
solder them together and file them down so that they look right and everything else. And when you put continuous rail across the thing, you basically will eliminate most of that chance for it to fall.
Yep.
The only thing there at that point is somebody might, if somebody bumps it while it's going across, there's no stopping it at that point.
It's going to be pretty hard to bump, and everything will be pretty rigid around this arrangement.
It's going to be pretty hard to bump, but yet you're going to have partial towers hanging from that bridge.
No, there won't be anything hanging. The bridge will just be clean without the towers. All it'll have is the little square. It'll have.
When did you make that change? Because you said you were going to have portions of it hanging.
I've thought about that on and off for a long time. I've thought about a bunch of different.
He's basically just talking about the rectangle piece that it sits on.
Just a little framework.
One little edge.
So that little edge, just the top little edge, just the top little piece of framework, so that you know that a tower belonged there, and to explain the divisions in the panels where they are. I'm going to model that for the two towers that are excluded. I've thought about it a bunch of different ways. I wish I could.
Here you go, Ralph. Tim just answered your question.
Oh, yeah, okay.
Yeah.
And I really wanted to, find some better way to solve part of this problem, but there's just no good. That's just compromises I have to make. And I have an idea. This is the actual exact bridge too.
You heard that, Robert. He said,
I didn't hear nothing.
Compromise.
There has to
I'm
be
Switzerland in this thing, all right?
Yeah, there has to be some, but I have some ideas about how to continuously weld the rail. What you really need to do, soldering will only go so far, and maybe that's all I can do. I'm going to
here you go.
But soldering will only go so far. Absolutely right. So that's what I'm thinking too as well, Adrian. I've got 2 ideas about this. One, we talked a little bit amongst us several times about the spot welders that weld that you weld 18650 batteries with. These kind of batteries.
Here we go.
Well, so
listen, if he doesn't
another rabbit hole.
If this guy doesn't stop it, I'm just gonna kick him from the channel.
I would like to. I'd like to have one of those spot welders anyway for 18650 battery pack rework anyway. So I'm going to test it and see if I can weld the rail together with a spot welder. I mean, they're like $50 for a spot welder, and I'm going to buy one for other reasons. And why are you thinking for? I started out steam. That's why I have all these pictures. I was originally modeling 1950, and then I realized I was not as wealthy as I thought I was when I started this project 6 years ago. steam, I'm in admiration of people who model steam successfully at any scale. But from everything that I see about the hobby, I think you either have to be doing something very constrained, like a small layout or switching layout with very few locomotives or something, or you have to be considerably wealthier than I am in order to successfully model steam as a power. Now, early diesels, or if you were modeling transition and you didn't need very many steam locomotives, but if you're modeling 1950 on the Norfolk and Western, where it's all steam all the time and big articulateds, I just couldn't afford to buy locomotives that ran well. I couldn't afford to buy 30, 40 locomotives that ran well.
So listen, I think if you're gonna be as prototypical as possible here, I think you need to explore using thermite welding.
Yes,
to do your rails.
There we go.
Oh my gosh. So I'm not going to do that. I do have some experience with thermites, coincidentally, but so that's what we used when I was in the military to destroy technology. We used thermite, so I have a bit of experience with thermite, but I'm not going to try. I'm not going to try anything like that. But I may just take a little.
I mean, you only need a couple of pinches, if that. I mean, it's not like you're using a pound.
Oh, no question. A little bit of rust, a little bit of aluminum, a sparkler, you're good to go. But
don't forget the cast iron mold that goes on the side of each joint.
Yeah, it's not.
Just get some of that. Just get some of that kinetic sand. You should be fine.
I think solder will do the job, especially if you put a little brass strip across the bottom. Solder's problem is solder is not structural. Solder is an electrical bond, and to keep oxidation out. So at least the way I was taught to solder years ago was you wanted your wire connection. So if you're hooking two wires together, that's why you use like a lineman's knot, so that you tie little twists so the wires are tight, and then you solder to keep oxidation out and to make an electrical bond, not a mechanical.
Okay, Andy.
But you can use silver solder. Silver solder.
Andy, you're not building this thing so you can stand on it. You're putting the track together so it stays together. That's all.
Okay.
Your track is being epoxied to the top of the channel.
Yep. And the channel's not going to move enough for a solder to.
So it doesn't matter whether the lead solder we use for doing our soldering and railroading is structural or not. It will hold the joint together because there's no flexing in it. It's the flexing that breaks it.
Absolutely. And there may be a slight bit with expansion and contraction, but I think, as you suggest,
there better not be.
I agree with you that the entirety of the bridge will have some expansion and contraction because it's aluminum. It's going to expand slightly, but especially if the rail joiners have a little room and the whole bridge can expand and contract slightly, I don't think it's going to cause a break. And I'm only going to have one. It's a 6-foot bridge. 2 rails will cover that bridge length.
So wait a minute, because I've heard this argument a lot from a lot of different people about the considerations for expansion and contraction. Okay, I can see kind of the argument with wood expanding and contracting, but when you're talking about metals, like, dude, you've got to get like below 30 or above like 400 degrees before you're really going to see that. And I'm just throwing out round numbers just for the sake of the argument.
With steel, you're absolutely
even aluminum. Even aluminum, your room is probably sitting at 70 degrees. It might jump and dip 5 degrees. You're not going to get any expansion and contraction out of 5 degrees.
Unless you had some unusual constraint. If we had a significant storm or something that knocked power out for a while in the winter, which has happened. I mean, there was 2 weeks without power one time 15 years ago. Here.
Okay, so your track is going to shrink then. And since you don't use rail joiners, it really doesn't matter.
Yeah.
Not generally. I mean, it could get, you could have such situation. Anyway, expansion and contraction gets blown up as this big deal. It's not. If you have the thickness of a piece of heavy paper between a rail joint ever so often or something,
but you don't have to convince me of that. You have to convince yourself of that.
Right. Yeah. Because here's the reality of the situation. Okay. Everybody's made a big deal out of this expansion contraction issue. Okay. My layout has been in my garage for the last 3, almost 4 years. Okay, it's barely insulated as the normal garage would be. I have had 0 buckling. I've had 0 separation. Everything's exactly where I put it down.
It does happen to people though. They do get buckling, and I have seen it in person before. But it's one of those things like having a feeder on every rail. Is it absolutely required? No, it's just while you're doing it, it's so much easier to just account for having a 16th inch of play to deal with the
Yes, I would
Really?
typically agree with you there. But in your case, no, because it's just one more thing to slow you down and get that paralysis by analysis.
Well, I'm
So
not. The bridge has to be removable anyway.
somebody commented about somebody makes
Oh,
these
those are so
things.
awesome.
Yeah,
Yeah,
Derek
well,
Alexander.
there's another one that they make that's made for modules,
Yeah.
and what happens is you have like this here between these two ties. It's like a sawtooth that actually aligns the two tracks together.
It's like a
So
puzzle piece or something. Yeah.
when you could use that on your bridge to align it once you place it down
Sure.
and run your whatchamacallits, your rail joiners.
I use printed circuit ties a tremendous amount. I mean, especially on hidden track work and at modules where I can hide the ends of it. And it probably makes more sense to do that on this bridge. Again, I don't think this bridge has to be removable all the time, but I don't want it to be a destructive process when I move the layout sometime later. So, but we
I
can.
I have the big arched bridge as well,
I
and
love.
it's 40 inches, so it's beyond a 3-foot section of flex track.
Yeah.
And I've made it so it's removable so that I can get into the town area because it's right in the corner, and I have to be able to reach in, and that bridge is in the way. So it's come out quite a few times, and there's no damage that's created when you take it out.
So see, I don't think the expansion and contraction issue, based on what I'm seeing through the comments here, is hit by everybody. I think it's just kind of one of those defect in the metals kind of a situation. It's not in every single batch, right? So
That's right.
Dan's model railroad journey had buckling in a temp controlled area, but then right past that, Adrian has his layouts in a basement, a humid basement, and has had no expansion and contraction. Mine's in a garage, which is as humid as it is outside, and I live in Western Washington, and
But
I've had no issues.
humidity doesn't cause the expansion contraction. It's the swing in temperature that does.
That's right. And
Humidity will increase. He uses homosote as underneath his roadbed. The homosote will absorb a lot of humidity and cause the rails to do this because
Right.
the homosote wants to move.
yeah, I mean, I seal it too, but the biggest thing that I would say that about expansion and contraction. Oh, and we're going to end in just a minute, guys. If you guys have any other questions that we haven't covered, we've run for about an hour, so we'll give it another minute or two, a few minutes to give it the last
I mean,
question.
I was kind of hoping it'd keep going. We were having a good conversation.
Well, I'm good to run for a little while longer too. I just I don't like to run it too long for people. But if everybody's still conversing, I'm happy to keep going. I enjoy doing that. I think that the argument about expansion and contraction is it's just an easy thing to solve for on a large layout. I don't think you have enough expansion and contraction over 6 feet to worry about, regardless. But when you have a
Right.
larger layout, expansion
Exactly.
and contraction is a compounding problem that can little bits of minor moves that wouldn't matter can compound to become a more significant problem.
Okay, so when we see our expansion joints getting bigger or smaller, it's not because of the metal. It's because of the wood frame that we've built it on.
Sure.
And
Yeah,
that absorbs the moisture. Like in the wintertime, I have no problem whatsoever opening up my gate. In the summertime, it sticks.
yeah. Well, the house moves. I mean, you've built a layout that's
I would
connected
think that
to
would be the
wall.
opposite.
No, with the humidity, it makes the wood swell.
Makes everything bigger.
It makes it harder to open the gate.
Well, and as things warm up, they get larger, except for water and ice. That is in direct opposition to every other chemistry in the world. Ice gets larger.
Well, I hope my place never warms up like that because that would mean I'd have my smoke detectors going off and so on.
Right.
If it gets
Just
that warm, yes. But if it gets larger, things get larger when they get warm.
See, I also think the materials you use in your layout have a big impact. Like Homosote's going to soak up water like a sieve, and humidity is water.
Yeah, you have to.
See, I don't use that.
And that's why I don't use it.
I don't use it either. I use the Woodland Scenics foam roadbed is what I use, and I use
most part,
extruded foam.
See, I just don't know of another good product as a replacement. I have been experimenting with Bicor. I've got a turnout built right now that I'm building on a product called Bicor. I actually like it better. It's just not as available. The availability is not as easy as Homosote. But I haven't found another product that I could use to replace Homosote. I despise cork. I despise cork.
As we move forward, it's going to be harder and harder and harder to find Homosote.
But that's why I'm looking at going to Bicor, because that is an available product. It has a much more modern commercial use than Homosote does. So Homosote is still available for now. Also, Homosote is fairly imperfect. It has a lot of undulations in its surface, where Bicor is very dimensionally accurate from factory. So I like Bicor better, but it's not as available as Homosote. It's a little denser too. But I despise cork for 1,000 reasons. I don't like cork. I have no condemnation to anybody who does like working with cork. I do really like the road bed that Ralph uses, which is EVS foam or neoprene foam, not neoprene.
Well, it's not even neoprene. It's
EVS.
Air conditioning pipe insulation that is in a tape form.
Yeah. But they call it EVS is the chemistry, EVS foam, but they make EVS rubber too. It's just different chemistries. I could tell you what EVS stood for, but it's vacuumized something, expansion vacuumized something. I've read about that, but I can't remember right now. That's a great roadbed. I use that in hidden track work. I mean, you've completely sold me on using EVS foam when I'm not head laying. It doesn't work for separate rails, separate ties, and all the detail parts. I can't lay them on that. And I don't have a good substitute for Homosote or Bicor or a product like that. I mean, I've seen people hand lay on sheetrock, actually. That used to be really quite popular for hand laying.
Yes.
So, I mean, there are substitutes. They're just not great substitutes that'll hold spikes, that can be dimensionally perfect enough to hand lay track on, and that are acoustically valuable, which I don't think cork is any of those things. I don't even think it's acoustically valuable. But you have to have something that provides acoustic. I mean, I've known people who years ago used to hand lay on Silatex, tiles and stuff, but they don't hold spikes very well. So you have to use printed circuit ties or, some other component, which I don't use a lot of spikes. Most of mine is adhesive-based construction, but.
Yeah, no, you had it right. Oh, why is it disappearing?
I don't know.
There it goes.
That's
I think all three of us were trying to bring it up at the same time.
Yeah, you just got to. All I suggest is it's just like having a feeder. Do you need a feeder on every section of rail? No,
So,
probably not.
Heath, you have to remember, Andy is way down south. Robert is out on the west coast, and you're on the east coast, and I'm just north of you, on the east, sort of. So I don't see the big temperature swings. I don't see the extreme humidities, because the humidity that we have in the summertime, yes, it's higher than it is in the wintertime, but we have high humidity in the wintertime too. So
we have pretty extreme temperature ranges, and we have pretty extreme temperature ranges like over the last week. So the shifts in temperature are more significant than the shifts in humidity. My only thinking about that is belt and suspenders. It's just too easy to plan for, so that it isn't a problem. And I have seen it, and you could go look. You could go Google image search for buckle track, and you'll see people who've had that problem. It's just really easy to solve. It's really easy to plan for.
Okay, so this is, it's not bridge related, but I've seen so many articles about when you have gaps in your rails, you put them there for expansion, right?
That's what I've seen as well.
We all agree on that?
Okay.
But I've also seen where they'll take a piece of styrene plastic and epoxy it into that gap to maintain it, and then shape it to the track. And when you paint your track,
yeah, I've always wondered what the point of that was.
Well, and now there's no room for expansion or contraction.
Exactly.
I use clear acetate, just super thin, glued to one rail. I put glue on one side, so the other rail can come and go if it needs to, because I spike and have paper.
Yeah, but you also put notches in the top of the rail so you can hear the clickety clack.
No, I don't want to hear it. No, it's entirely a cosmetic thing. I do not think you can make it sound anything prototypical. If you cut gashes in the rail every 5 1/4 inches or so for 39-foot track, and you can hear that, it doesn't sound realistic. Sounds scale, and it doesn't sound right. If you want the click clack sounds, you're going to have to do that digitally. That's going to require your Arduinos or whatever players to make that sound effect. You can't cut gashes and make it sound good. I cut those slits in the tops of
Sounds
my
great to
rail.
me.
When I cut those slits in the tops of my rail and put fish plates on them and then paint it all and then wipe the paint off, so there's a little paint that goes in that little line. But I file that and sand that smooth, so you can see the little slit in the top of the rail at the break point where the fish plate is. But it's a cosmetic consideration.
Look who's come to visit. Clark
Hey,
Kooning.
hey, Clark.
Clark, buddy, how are you?
And I use slide as well, as long as I'm not in yard sections like I've been building recently. And even my yard sections are flat deck homosote with homosote splines underneath. And then all of my single track and where this bridge I'm building, each end of this bridge as it goes past the abutment will be going on to homosote spline.
Okay. So we just about talked this one out, or what?
Yeah, it's only taken us about 2 years.
We
and
still haven't convinced you to go straight, but what the hell?
Well, I've got one bridge that's going to be straight, but I'm going to try to get this slight curve.
I mean, Ralph, I've been trying to convince him to go straight for years. He's still drinking that Perrier water.
Oh,
that's true too, and that chocolate milk thing.
Yeah,
I've calmed down a little bit. I've calmed down a little bit on chocolate milk. Yep, but yeah, we were a little bit long, but this was a good conversation. But this is an hour of us trying to describe and still maintaining the arguments that we've had for a while about this thing. We've been talking about this for 2 years, and I'm finally getting really started on it. The modules that I've built recently on the Empire series, butt up or adjoin to. The very next module I need to build is one of the modules that this bridge connects to. So this bridge needed to get built so that I can move on with modules that go on around the room from the modules that you've seen us build on the Empire series. And next year's Empire series, I'm going to be moving on with that project as well. So,
okay. So what's the schedule for your build show for the season? What we can expect?
There'll be one show a month. I don't know how. It's hard for me to predict how many shows it's going to take for me to construct it. That's one thing that I learned from the pre-recorded content that we were doing with Empires. It's very hard to predict how much content you're going to get out of recording. I mean, I remember times when we were working on recordings and I would record a bunch and I would end up with 8 or 9 minutes. And I remember another time where I done basically the same recording. Actually, I think I told you I thought I was short and I had 30 minutes worth of video. So it varies tremendously. But I anticipate it will take about 4 shows, possibly 5, to conclude this. If it takes 4, then we'll have another live show wrapping it up with the bridge hanging in the air or something like that. And then I should wrap it up just in time to start back on Empires. That's my hope. And there's other things to build if it moves faster than I anticipate. So, but Ralph's got a really spectacular bridge to build as well. So, I mean, don't let him off the hook completely. I'm not sure how long it's going to take. I'm not sure how long it'll take him to build what he's working on either.
I have a Howe truss bridge that I want to build.
That's a beautiful thing. Doesn't fit mine for a bunch of reasons, but it's beautiful. And yeah, Sparky, I do have a functional layout, and a couple people have been here. Joey, I'm sure I can't pronounce that. Joey's been here.
Joey G.
Joey G. That's there you are. Joey's been to my house before. Not a lot of people have seen it in person, but a few have. But my hope is in another year and a half or 2, I should have it to where it will meaningfully operate. And with all the recent changes and adjustments, going to the C-frame construction, widening the aisles, it's going to be much more accommodating. I originally thought it'll just be me maybe I could have one more or maybe two more at most to ever operate the layout. With the current design, I think I could accommodate 5 operators in a layout that's in a 15 by 15 room with 200 feet of visible mainline trackage, a 90-foot modeled branch line, 60 foot of a second railroad, plus all the staging and hidden track work to accommodate that. And I can still accommodate 5 or possibly 6 operators relatively comfortably in 15.
Did somebody say bowl of spaghetti?
It
pretty
looks
much.
that way looking from the top down, but when you're in front of the layout, all you can see is the one track that's right across in front of you.
I'm still trying to figure out how you make sense out of that plan that you've got when you look at it in that CAD program.
Oh yeah, it is.
Layers are your friend.
That's
no
right.
kidding.
Yeah, that's a big layers are a big deal. So, and I have I don't 120 or 30 different layers, so I could turn things off so you can get an idea of what it looks like without the branch line models.
Each element has its very own layer.
Yeah, I could turn all the
He's got a million layers just for trees.
So that's right.
Pretty much.
Yeah, you could get scenery, road structure. So there's those 3 elements, but that's the circle of main line around the top level without the branch line. That's just it comes up right here and works its way around underneath here, pops back out again across this bridge, goes through the wall, back out of the wall, back around this way, circles around hidden, then goes around those bridges, then over the top. It's not that complicated. Now, keep in mind, from a visibility perspective, though, you can only see. Actually,
hold on. Let's recap that. It goes over this way, it turns back, and goes this way. It does around over this way, it goes back over here, turns around again. It's not that complicated.
Sounds like that amusement park ride. What was it? The Wild Mouse or something?
Oh yeah, the Wild Mouse. I remember. But remember, when you're standing in this aisle, all you can see, for example, is let's see,
a 7-foot bridge.
All you can see is this segment here, which it'd be better to turn that stuff back on. All you can see is this stuff that's in here. That's it. You can't see anything outside of this aisle, and you've got the raised floors that put you up to height. So, but that's all you can see, and all of this here is this track work here is 79 inches basically. This track over here is at 86.
Ouch.
So it's way up there, but there's raised platforms. But it's all broke out in ways where there's a viewing angle. So all you can see is when you're in this area, that's all you can see.
Anyway,
it's
boys.
very constrained. So we'll have a show produced for next month about the same time. We'll probably drop it on that Saturday, pre-recorded of me actually constructing this crazy thing. I'm real interested in the actual construction of it as well, and then in the future you get to see it implemented into the layout too. But it's a big project. That's why it's taken 2 years of thinking and talking about it. Plus, I had time. I was working on other parts of the layout, but now it's time to move on and build this thing that I.
No, it's taken 2 years because we've been talking to you. Trying to convince you. We've got you switched over on a few things.
You have. I'm completely convincible of anything with the facts.
If Andy was a superhero, he'd be Captain Analysis Paralysis.
There you go.
I do like to spend an amount of time thinking about things, but
obscene. Listen, let's call it what it is. Let's call a spade a spade. An obscene amount of time thinking about things.
An amount of time, yes. I do move on. I do go on and just build things sometimes, and sometimes at a certain point, the answer just cannot be discovered intellectually. At some point, you just have to build something. So that's how I decided to go on and start building the layout. The lower level, I just decided to commit and start building what I felt the most confident about fitting in. So, but we've run pretty long this time, a little over an hour. So we'll have another show in 4 weeks and next month, and then we'll have a number of those shows as we actually put this thing together, as I actually lay out the paper templates for this thing and cut metal to go on top of it. So we'll see you guys again next month. I know we've got a few shows coming up, but I haven't looked at the schedule for when those are coming up. So, but
Well, Bill's show's coming up with the track planner.
Yeah.
absolutely, that's been a really good series. I've thoroughly enjoyed those. April
Um,
13th, 9 p.m. Eastern. Thank you, Bill. I've really enjoyed that series of shows. So, all right, we'll see you guys. See you guys next time. Thanks everybody for joining us.